So the topic is prime numbers, and prime numbers are those numbers which
Are
are
you gonna introduce yourself first?
uh, no, it's not necessary. So I'm doing a session with Alysa, um, and we are learning prime numbers. And do you know what are the prime numbers, Alysa?
So the prime numbers are the numbers that cannot be broken down into any further.
Yeah, which cannot be divisible by or divided by, which cannot be divided by any other numbers except itself
And one.
and one, right? So except one and itself. Now, for example, 3 is a prime number because 3 you can write 3 times 1. There's no other factorization. But 4 is not a prime number. You can write 4 as multiplication of two other numbers, right? 3
Yes.
is a prime number because there is no other factorization of 3 except 3 times 1. But 4 have this one and the obvious one. What is the obvious one? Obvious is 4 times 1, right?
Yes.
So that's why 4 is not a prime number. How about 5?
One.
Yep. 5 is 5 we can write it 5 times 1. That's the
Five is a
factorization,
prime
yeah.
number.
So we don't have any other factorization for 5. 5 can be written as 5 times 1. There's no other two numbers which multiply to 5.
Five.
So
Okay.
so the 5 is one of the prime number.
So six isn't a prime number though.
6 is not a prime number because we can write 6 times 1. That's true, and we have more than one factorization. That's the one of the factorization. 6 also can be written as 2 times by 3, right? 2 times by 3 is 6. So 2 and 3 are not the same, like, they are not the trivial factorization. Trivial means like that. This is the trivial. 6 is 6 times 1. So we have a non-trivial factorization, therefore 6 is not a prime number. So let me cross it. Not a prime, that is prime, this is prime. So these are the examples. Um, what else? How about 13?
13.
We can write 13 times 1, right?
It's not. It is.
Yes, that's right. We have only obvious factorization, and that is that. And there's no trivial, non trivial factorization. Like 6 has two factorization, trivial and non trivial. Like you have two other numbers which also multiply to 6. But in 13, we don't have any other two numbers which multiply to 13 except itself and 1. Now, the next thing we will talk about prime factorization quickly. What is the prime factorization of 48? Let's do 48. I can write it down
I
here.
see.
Prime factorization. So prime factorization
Of
is a fact.
48.
For example, 48. Yeah. So let's break it down.
That's a prime.
Yes, that's not a prime number, so we can break it down. We have to break it down to the prime numbers. We are writing factorization and which is prime, right? So we are doing factorization which is prime. So let's break it down. Uh, 48 is 48 is 2 times by 24.
2. Yes.
Yeah. And you can break down 24 further. No, no, it's all right. 24 is 2 times by 12, right? And how about 12?
12.
Mm-hmm.
Um, break. And then
2
break
times
down
6, right?
12.
2
Yes.
times 6.
Yes,
Uh,
and then break down 12.
So we keep doing it until we get all prime numbers. Now 6 is not a prime number yet, so we break it down further. What is that?
Which is 3.
2 times 3
And
is 6.
then that's a prime.
Yeah, if you look at all those numbers, there are 2's and 3. So 2 is a prime number. We already know that. We discussed it right there. Sorry, I didn't write. 2 is also a prime number because we have 2 times 1. Only
Yeah,
one.
I knew that.
Yeah.
I knew that, but you didn't write it down.
Yes. So, do you think that 1 is a prime number? Now that's a nice question, though.
Yes, I do think that 1 is
Now
a prime.
that's kind of surprising. In math, we don't consider 1 as a prime factor because there's no possibility of breaking it down. That's the really primal number, right? So I mean not a primal, I mean it's a basic number, really basic. So there's no question of breaking it down. So 1 is not a prime number. We don't consider it as a prime number. 1 is not a prime. I thought you were doing that.
I always let my hand up like this because when people are speaking,
Mhm.
so that I don't interrupt.
Oh, okay. So prime
If you're
fact.
uncomfortable with me doing that, I could stop.
No, no, no. It's all right. I'm comfortable with almost everything, which is not that. Like, yeah. I don't know. Anyways, so the prime factorization is that what we learned right now. It's a prime factorization. We break down a number up to the base. I mean, base means we find out all the prime numbers. So let's do one more example with um let's do for um 36. Let's find prime factorization of 36.
So, the prime factorization, 36.
Yeah. 6 times 6, you know that, right? 6 times 6 is, yeah. We already know that. Now 6 is not a prime number. We can break it down. What is that?
3.
Those two numbers.
3.
3 times 2, yeah.
Yep.
And in the same manner, this 6 can be factor out 3 times 2. Now if you look at these numbers, we have 2 3's, right? 3 times 3. How many 3's are there? 2. So rather writing 3 times 3, we can write, let's just see, I write all the 3's together and 2's together.
Yes, I see that.
So 3 times by 3, we write 3 powered by 2.
Can you move your screen a little bit
Sure,
closer
sure.
to me? It's
Sure. Just wait for a
easier to
second.
see.
Now that is that. Next thing is we can write 2 squared multiplied by 2 squared because we have 2 3's. That's why we are writing this 2 on the top of that. And we have 2 2's, so we write 2 powered by 2. So we have that's the prime factorization. So we got a prime factorization for that. Now you understand that?
Yes.
Good. Now we learned prime factorization and prime numbers, and the next topic we will talk about LCM and GST, and
What?
it's the same thing. I mean, it's a greatest common.
Oh, I was like, what?
I mean, it's slightly different concepts. So we'll talk about that. probably I can give you one kind of quick hint about it. Um, these numbers we call them factors, and that's the multiple. 48 is multiple. 36 is the multiple, and these are the factors, right? Now
Yeah.
we'll talk about the least common factor, LCM.
Yeah.
Least common multiple, LCM,
Mhm.
and greatest common factor, greatest common factor,
Mhm.
or LCF, largest common factor. Let's do that in the next video. So you can watch my YouTube channel, London Math Solutions, or go to my website, www.londonmathsolutions.ca, for more videos. Thank you.